Thank you very much. It's an honor to be here. I'm very excited. This is my first trip to Korea. Seoul is a very lovely city, and I've very much enjoyed my visit. I'd like to say a big thank you to the organizers and the sponsors. People put in an incredible amount of behind-the-scenes effort in order to make something like this happen, and it's very exciting to be part of the Agile Korea reboot. And I particularly want to say thank you to the organizers and sponsors. So why are we here today? We're here to celebrate because Agile has won. This is from a report beginning of the year from a company called Version1 who make Agile software, and they said 94% of respondents in their survey were doing some form of Agile. So Agile has won. Agile is the right way of doing software according to lots of people. 98% of respondents in this survey reported they had realized success from Agile projects. In particular, they had seen accelerated delivery, improved team productivity, better project visibility, and better management of changing priorities. And that's one of the core features of Agile, is responding to change. Change is inevitable. Agile is a way to help you respond to that change. But we still have a long way to go. So if you look at this graph, 80% or more of companies still have a long way to go in their Agile maturity. They report they were at the still maturing or lower level, with only 18% feeling that they had a high level of competency with Agile and Agile processes. So it's great to see a conference like this, which is helping to spread Agile through the world and here through Korea. So this is just a little bit of a reminder of the Agile Manifesto from 2001. So this is 16 years ago that this was written. And the people who created the Agile Manifesto, they really believed that Agile was the right way to do software, that they had discovered a new way of creating valuable software through these methods. And so what I wanted to do today, as we are restarting Agile, the Agile conference in South Korea, is to talk about what we have discovered in the last 16 years. This is a talk about ThoughtWorks' view of what good looks like for enterprise IT. So I'll talk briefly about ThoughtWorks. I know Hubert said some things already, including talking about the tech radar. So ThoughtWorks has been in operation for 24 years now. We've been doing Agile for probably 15 years. We are at 4,500 people. We're in 15 countries. And one of the primary things we do is Agile for the enterprise. So we bring leading edge technology and techniques to large organizations who are doing software. In the past, we have brought Java, .NET, Ruby, all to the enterprise and championed that technology's use in a large IT organization. In addition to technology, we also do a lot of process stuff. So continuous delivery, we wrote the book on that. Sketch to code, which is a technique for having designers work closely with developers to design and produce software. We're a big part of that. And we're large champions of the DevOps cultural movement. In addition to being part of those things, ThoughtWorks also produces products. We have a products division called ThoughtWorks Studios. One of the earliest products we created was something called Mingle, which was the world's first Agile project management tool, which included a virtual card wall so that you could manage your project using that tool and also have distributed teams collaborate and share a card wall. More recently, one of our big projects is something called GoCD, which is a continuous delivery pipeline tool. And one of the things that is happening in the Agile enterprise space right now is continuous delivery, which I'll talk about later. So ThoughtWorks has created a tool to help with that, and that's open source. ThoughtWorks' mission is to champion software excellence and revolutionize IT. And we take that mission seriously. So one of the things that we do when we talk about championing software excellence is to tell people about it. We talk about what does good software look like. We've written over 80 books. We have the technology radar on the side here that Hubert mentioned. We publish that twice a year. We have 25,000 subscribers to the Tech Radar. It's free. There'll be another one in a couple of months. And in addition to the books, we also speak at conferences. We create open source software, and we do the products that I already mentioned. So today, we're going to look at what does good software look like? What does good software development and IT practices look like? And what I wanted to do was use these different levels of scale to examine what good looks like. So we're going to start with an individual developer, which is kind of a foundation level. And we're going to move up to street level, which is a team, up to kind of an apartment building level, which would be a collection of teams, and then all the way up to skyscraper level, which is very large organizations. So this talk is about what we think good looks like in all these cases. And I'm going to use a number of lenses to think about this. So when you think about what an individual developer does, you can think about technical practices, architecture and platform, collaboration, and design. So we're going to use each of these lenses to consider what is good. And what we'll see is that for each of the agile practices that I talk about, they can be good for more than one of these things. So you might see something that influences, it seems like a technical practice, but it's actually also about collaboration. I'm going to go fairly fast, so I'm going to be talking a lot about why we think these things are good, and the specific details of what exactly do I mean by microservices. Well, I'm going to talk a bit about that, but if you want to know more about microservices, there are other sessions today and other information where you can get a deep dive into those specific things. So I wanted to start with the individual developer. And so Scrum is one of the most popular agile methods. So it's a set of techniques for doing kind of iteration management, story writing, estimates, and project planning. The thing that we learned about Scrum was that it was very good for sort of the project management piece of software development, but it didn't say so much about the technical practices that you need in order to succeed. And what Scrum projects were seeing was that developers needed more technical skills, more technical excellence in order to be able to support the Scrum style of project. So to do Agile well, you need great engineering underneath the process. So one of the first things that we think is important is the fundamental cycle for developers, red, green, refactor. So creating a test to demonstrate new functionality that you want, making the test pass, you get to a green bar, and then refactoring to ensure that you keep clean code. And something that is sometimes quite difficult to do is test-driven development, where you're writing tests before you're writing implementation code. But if you can learn to do that, it's actually a useful design technique, because writing tests before you write code actually improves the design of that code. And so that test-driven development is kind of design at the individual developer level. The testing pyramid is something that is always important to pay attention to. So if you think about the kinds of tests that you have in your software, you start at the bottom of the pyramid with unit tests. Unit tests are cheap, they run fast, and you can have lots of them. As you move up the pyramid, you get different types of tests. Service tests where you're testing a single service, integration tests where you're testing multiple services connected together, and then maybe even UI tests where you're driving a browser or an app actually through the UI. As you go up the testing pyramid, tests get slower and they become more expensive. And so what you need to have is many unit tests and fewer UI tests, because then you can keep the cost low, you can keep the speed fast, and these things are useful. What we see a lot of is something we call the testing cupcake rather than pyramid, where you get kind of fat at the top. It's not a pyramid anymore, it's kind of upside down, because UI tests are easy to write, but they're slow. And the problem with a slow test suite is that it starts to become an anchor rather than a benefit. So good automated testing is kind of a foundation of Agile, and doing it well, you have to think about the testing pyramid. A couple of other comments about how developers work. You should have a command line build, a repeatable build that you can always run and get the same result. Builds should be fast, preferably under 10 minutes for a complete build, including testing, and frequent commits. So developers checking their source code back into Git or whatever source control you're using, but doing that frequently, so multiple times every day. I'll move on to talk about an Agile team who are collaborating on a project. So pair programming is a fundamental of Agile, and there are differing schools of thought on pairing. One of the big things about pairing is that it's very visible to people who are paying for software, because it's very clear that you're now paying for two people rather than one person to actually create the software. And the usual question is, well, doesn't that cost twice as much? Productivity in development is difficult to measure, so sometimes it's difficult to answer this question. But there are actually many academic studies that show that pair programming is efficient in that it does not take twice as long as using a single person. You get higher quality code, and more importantly, you get much better knowledge sharing amongst developers. Something that I think it's important to remember is that the act of programming, much of that is actually learning about the problem that you are trying to solve. And so pair programming can help more people learn about the problem and how you're solving it, and therefore that can increase efficiency. So continuous integration is something that lots of people think that they're doing, and actually they're missing some piece of it. So with continuous integration, every developer is checking in their changes to the main line of development every day, so that all of those changes can be combined and integrated. That's what the word integration means. So everyone is coding and sharing their code, and then you understand whether the code, as it is combined, still continues to work. What we see a lot of is something we call continuous isolation. And that can be where developers keep the code on their machine for a week because they're still working on it, they haven't finished a feature, or where you have excessive branching in the code base. And I mentioned trunk-based development, and I think this is really important to talk about, because this can be a big barrier to achieving good Agile delivery. So trunk-based development is where everybody commits their changes to that main line of development. Everybody's sharing their changes all the time. In a lot of organizations, we see lots of branching. You create code branches and then use those code branches for different purposes, usually for developing a feature on the code branch. The problem is, branches are not free. Merging is painful, even with modern merge tools. And a lot of organizations use branches to try to cherry pick features for a release. And they use branches instead of actually doing good project management on the features. So we think excessive branching is a smell. But how do you avoid branching? One of the techniques that's very important is feature toggles. So this is kind of the secret sauce for trunk-based development. With a feature toggle, something that is half finished, it's not ready for release, you can still check that into the code base because you use a feature toggle to switch it off. So combined with good automated testing, you know that a half-finished feature has not broken some piece of software that was working. Facebook, as an example, has features that are deployed on their production servers right now that are half-finished and that we will not see as the public for another 6 months. Those features are on the Facebook servers, but they are toggled off using feature toggles. Continuous delivery is something that we advocate. There's a really great book on it by Jez Humble. And it's different than continuous integration. I see a lot of people writing CI, CD kind of together, and they are very different things. Continuous delivery is about creating a pipeline for changes to move from developer workstations into production. So as changes flow down the pipe, you gain increasing confidence that that version of the software is ready to go to production. So we might start with unit testing, regression testing, automated regression testing, some manual testing in here, followed by a push through to production. So continuous delivery does not mean that every change always goes to production, but it means that the software is generally ready to go to production. One really important thing about continuous delivery is it takes the decision when to go to production. It puts that decision in the hands of the business, in the hands of people who are going to realize value from the software. In many traditional environments, the choice to put something into production can be a big choice and take a lot of time. And so the thing about continuous delivery is it moves that decision into the hands of the business because IT can always say yes, because the software is always ready to deploy. So we'll talk a little bit about teams within an organization. How should teams collaborate? First of all, I'm going to take a bit of a detour into software architecture. So Agile software architecture is a big topic. How to do architecture well for an Agile organization. First of all, I want to say that software architecture is important again, mainly because companies like Netflix have shown us that you can build significant things in a short time using cloud-based infrastructure. Getting architecture right is the key to unlocking these capabilities with cloud. So software architecture in the cloud era has become increasingly important. Agile doesn't mean no architecture. Agile doesn't mean no design. When we think about architecture, I think about architecture as the things that are difficult to change. Usually when you make an architectural decision, you are committed to that decision for some length of time. So you need to be careful about those decisions. But Agile has a principle of the last responsible moment to make a decision. So with Agile, we try to get as much information as we can before we make that decision. With architecture, that last responsible moment may actually be quite soon. It might be quite early in a project. So with architecture, you need to make decisions late enough that you have information, but early enough that you have time to carry out that architectural vision and direction. Agile depends heavily on automated testing. So a lot of the things that I already mentioned were things like pipelines into production and test suites, the testing pyramid. All of this stuff is about automation with your testing. And there's an extremely important link between software architecture and the testability. So on Agile projects, we often like lightweight components. We like loose coupling. We like things that we can tear down and rebuild easily. We tend not to like some of the kind of heavyweight traditional infrastructure. That's because these things that are lighter weight and more loosely coupled are easier to test. So if we want to automate a whole bunch of things and gain confidence that the software and the system is working, we need architecture that promotes testability. Spotify have written a bunch of stuff about how they do Agile. Spotify is a music streaming company. And there's actually a lot of really interesting data and information about their engineering culture. When they do architecture, basically, architecture is a trade-off between consistency, standardization, and efficiency versus flexibility and innovation. And usually the answer is not complete flexibility, and it's also not complete standardization. The right answer for architecture is somewhere in the middle. It's a balance. With Spotify, they have individual teams who are empowered to make decisions about the way they build software, including the architecture that they use. And then they promote this method of cross-pollination, where they share ideas between the projects and between the teams, so that the best ideas over time can be adopted by more people. And so they try to maintain this balance between consistency and flexibility. I like a simple model for architecture. Standards that everybody has to agree on and you have to stick to the standard. Recommendations that you would use in the absence of a better idea. And advice based on the architect's experience. Something that we think is really important for architecture is that architects are part of delivery teams. So architects tend to be part of a central architecture group, which is appropriate because the architecture group needs to define an architectural vision for the organization and help people move towards that vision. But architects also need to be part of teams. They need to understand the effects of their architectural decisions on teams who are really trying to deliver software. And that's very difficult if the architects are not part of a team. Successful architecture is actually the success of delivery teams who are using that architecture. Success of architecture is not just producing an architectural vision in a vacuum. It's worth mentioning kind of team size and structure and interfaces here. So who's heard of the two-pizza team popularized by Amazon? Yeah, a few people have heard of that. So Amazon has a rule that no team is allowed to be larger than you could feed with 2 pizzas. So that means, you know, maybe 6 to 10 people, depending on how hungry they are. And the point is to have smaller teams so that communication is more natural. Because once you go above 6 to 10 people, you can't have a single conversation. If you're at a dinner party and you have people talking, what you'll usually find is once a group gets beyond about 6 people, that group will start to splinter into smaller groups so that they can maintain an individual conversation. So the 2 pizza team thing is about keeping teams small enough that natural human communication can still happen for them. Helps avoid the overhead of more formal communications. And then when you are talking between teams, it does help to have some formality. So we think a lot about APIs that teams are using to talk to each other. We talk about CDCs, which are consumer-driven contracts, and I'll talk about that in a moment. And those are all techniques for allowing those small teams to collaborate effectively. Consumer-driven contracts are a pattern for service evolution. Almost everybody is interested in microservices, and I'll talk more about that in a moment. But when you're creating a service ecosystem, even if it's larger services, not micro, just regular services, consumer-driven contracts are a way to help those services evolve. So what we have here is we have a service provider on the right-hand side, so creating a customer service, and we have a number of service consumers in our architecture. We have a billing service, an order service, and a marketing app. This is just an example of how things might work. And so this is kind of the live architecture, live infrastructure. With consumer-driven contracts, each of these consumers can create a contract, which is basically a description of how they use the service. So the order service describes to the customer service how it is going to consume it. And then we have a contract validator in the middle that can take this description of how these consumers will use the service and check that the service actually conforms to that. So you can say things like, I expect that there is a customer endpoint. And when I ask for a customer, I get a customer back that looks like a particular format. So, just back a sec. So the nice thing about this is that the customer service, you can change the customer service, and you still know that you didn't break any of the consumers without actually needing to fire up the consumers. You don't need to run the consumer code, you just run the contract. The other thing that you can use this for, you can do it in the opposite direction. You can use those contracts to create a stub version of the service. So if you want to test your marketing app, you can use these contracts running in reverse to test against rather than needing a real instance of the customer service. This kind of stuff can become really important in a large system with lots of services collaborating, because you need to know quickly that your system still mostly works together. And you need, this gives you early feedback on anything that becomes broken. So microservices, very fashionable, lots of hype. ThoughtWorks gets a lot of phone calls that start with, hey, I'd like to buy 2 microservices, please. And we've gotten better at turning that into real projects, but yeah. So microservices are a technique for breaking down a monolith into multiple small slices that are simpler individually, easier to understand, more reusable, and easier to scale. One of the problems with microservices is that because there is so much hype, people are just jumping straight into microservices without really understanding whether it's the right decision for them. So my colleague Martin Fowler has an analogy which is when you go to a fairground, you know you have those signs for the children that say you must be this tall to ride on this ride at the fairground. Martin talks about microservices in a similar way. You must be this tall, you must have this much engineering discipline and these practices in order to be successful with microservices. The thing about microservices is that you're trading complexity in the monolith for complexity in deployment and operations. So you need really good DevOps culture in order to be successful with microservices. I'll just give you a second to read this. So this one's subtle. So this is something that Melvin Conway wrote back in 1967. So this has been true for a long time. This was in the Mythical Man Month book, which is a classic book on software development. And really what this says is that however you structure your group of people who are creating software, the software will end up looking like that group of people. Specifically, the communication pattern in the software will match the communication pattern of the group of people. And we find that this is true for software engineering and for a whole bunch of other problems and people interactions in the world. So here's an example. If you have kind of traditional siloed functional teams, which is the traditional way of organizing a lot of IT outfits, you might have UI specialists and middleware specialists and DBAs. And they are separate groups, and they communicate with each other, somehow in meetings. That leads to application architecture that looks exactly the same. So the architecture mirrors how these groups are communicating. We have seen success with organizations deliberately using Conway's law to build software how they would like it to be architected. So you organize your teams you organize your teams with communication patterns as you want the software to be. And then the software that those teams create will have that communication pattern. So as an example, with microservices, you generally take a monolith like this and break it down into individual microservices. But each microservice will have a collection of people working together on a team for that microservice, so that you end up with encapsulated architecture and clear communication between the microservices. We also see a trend with teams structured around services or products, and I'll talk a bit more about that later, but teams owning an OKR, which is an objective and key result, is really about empowering teams to take a business outcome and move the needle on that outcome, to drive an improved outcome on that business metric. I've mentioned DevOps a couple of times. So 71% of companies are either already doing DevOps or they have a DevOps initiative planned. I think DevOps and microservices are the two hottest things in IT right now. DevOps is something that can be, I think, significantly misunderstood. DevOps is about bringing development and operations closer together to get better outcomes. It's about having developers understand a little bit more about how the software will actually operate. It's about operations people understanding a little bit more about the world of development. What we see, unfortunately, is many places are creating a DevOps team, which is leading to yet another silo. Things are slightly better because we're thinking about the bridge between the two, but if you have a DevOps team, it's just another silo. DevOps is a culture rather than a specific team. This slide is from a year and a half ago, from the folks at Puppet Labs, and they do a report called the State of Devops. So they create this report every year. Very interesting. So they looked at the difference between low, medium, and high-performing IT organizations. And that performance is measured by things like business satisfaction, value created, all of that kind of stuff. And you can see this yellow line here shows that high-performing IT departments deploy their software to production more frequently as they increase the number of developers, whereas low-performing, medium-performing organizations are just flat, and low-performing organizations, the more developers you get, the less you deploy to production. So there's kind of a pattern that high-performing IT tends to deploy faster, and that's one of the things that DevOps helps you with. It's one of the things that continuous delivery helps you with. But what's interesting is that this slide is from a year ago. This year's data suggests that many companies are trying to copy this trend. So they are trying to deploy more frequently because they see high-performing IT departments deploying frequently. But they deploy frequently, but with lots of failures. So they're putting low-quality stuff into production more often, and their mean time to recovery is longer. So they put broken stuff into production more often and take longer to fix it because they're trying to copy this. So for some organizations, they're not ready to deploy faster. They should just stick with their existing slower deployments. Enterprise CI and CD. So I talked about continuous integration and continuous delivery for a single team. What becomes very interesting is when you're trying to do continuous integration and continuous delivery across the entire enterprise. And this is sort of a piece of that puzzle. This is a pipeline. So this is a continuous delivery pipeline from individual teams all the way through to production. For each of these components, we've got a cart service, product service, order service, and an app. For each of these, we have a pipeline step, which is to compile and unit test. We have another pipeline step, which is service testing, using those consumer-driven contracts that I talked about. And once you've completed this, you have an idea that each service is working, and each service will probably work with the other services. Then you take the latest passing build from here, put it into an integrated environment with the latest best build from each of those components, and do integrated scenario testing. And again, all of this is automatic. So these green things mean that you get an automatic progression. So we're automatically putting the software all the way through to integrated CI. Then we might have another integrated environment where we're manually choosing builds to push into that environment, and we'd run some smoke tests on that. And then we have a QA environment where we do manual acceptance testing, which is a small amount of manual testing, and exploratory testing, where human beings try to break the software, because that's what QA people really should be doing. And then if all of that is good, we push to production. And the red arrows are manual steps. So we choose which builds to push all the way up to production. One thing about this is that it can be slowed down by bottlenecks, like having a single mainframe instance that you need to test against, or other kind of single points of bottleneck in the process. And when you get those kinds of things, then you need to think about how to remove that bottleneck. Something I mentioned a little bit was the Amazon style of doing things. We see a lot of success with teams doing a you build it, you run it style, where a team is empowered to create and run a specific piece of software. Because the team is running it, you build it, you deploy it, you run it, you support it, that means they need self-service infrastructure. So that usually means cloud, and it usually means the team being able to deploy on that cloud. That's not easy for traditional organizations. It can raise significant questions around security, testing, developers carrying a pager, and doing support work. Something that I think is very important is that having done the support makes you a better developer. You know, after you've been up at 2 a.m. trying to find a bug in somebody else's code, you're not going to create that kind of bug yourself next time around. It also doesn't mean no operations. Like modern distributed systems need more operations support, not less. I'll move on to very large organizations. Something that is happening in the industry is everybody is talking about platforms. So platform thinking is pervasive. Even the word platform is overloaded. So when I say platform, you might think of a traditional platform like SAP or Oracle in some way. You might think about an infrastructure platform like AWS or private cloud. You might think about a business platform, which is things like Salesforce.com that you would then use to build something else. So just the word platform is overloaded, and it's worth remembering that. The general important point about platforms is that they are something that you build so that you can accelerate something else. So you can create some new thing faster because you have the platform. whether that's a technology platform or a business platform. The key benefit on platforms is that they reduce friction. So we use friction as a word to describe things that get in the way of technologists being able to create value. And so those are things like, slow ticketing systems, all that kind of stuff that means things take a long time. We think API ecosystems are a really important development. So many companies are building internal APIs, treating those APIs as a product, and then finding internal customers for that API. And so companies can end up with a suite of APIs internally that are available to teams so that they can use that API to build something new. And in actual fact, there are many cases where the API is used in a way that was not planned. We have a lucky combination of things between a few APIs. We call it serendipitous reuse of these APIs. And what it means is that you can combine this stuff together to produce some new valuable thing that was not planned for, but that was enabled by APIs. And something I've sort of been alluding to is this emphasis on products, not projects. So most of us in IT are used to project-based delivery. We create a project, we get a budget for the project, we find some developers, and then we start doing the project. And once the project is finished, the project is done, so all the developers go back to wherever they came from, and all of that knowledge about what this thing was that you built sort of disappears. Having a product focus, so thinking about the things that you build as though they were a product that you are trying to maintain over the long term, a product where you're trying to find customers. Maybe it's an internal product, maybe it's an external product for external customers. Having product thinking enables you to have a much longer term view and a longer term evolution of those products. I talked a little bit earlier about ThoughtWorks Studios, and we create a number of products for ThoughtWorks Studios. We've found that about the minimum amount of time for someone to really, really understand the product is about 1 year. So if you think about that, it's important to have these kind of longer term products and longer term developers who are associated with those products. Something else that we're seeing is hypothesis-driven development. This is a very Silicon Valley thing to do, where you kind of come up with a statement of the problem that you're trying to solve and a hypothesis that you think will make it better. And then you use the scientific method, you run some experiments, and you test whether those experiments are going to improve the result. And then some ideas work, some ideas don't work. You kill the ideas that don't work. You double down, emphasize the ideas that do work, and then kind of go back to step one. Something that's really important here is that some ideas will fail. And the IT industry in general is not good with failure. Failure is something to be celebrated within Agile because it means you learned something, right? So failing fast and spending less money on a bad idea, that's a good thing. Something I want to mention is that the practices here within Agile software development, they reinforce each other. So smaller teams tend to move faster. So we like smaller teams, but those smaller teams are supported by good interfaces, by self-service platform infrastructure, by architecture that supports testability, by a product focus, not a project focus. All of those things combine together to support each other. Microservices are popular, but they require really good discipline. You need a good testing pyramid. You need consumer-driven contracts. You need enterprise CI. And you need a good DevOps culture. So all of those things combine to make microservices possible. the other thing that I'll mention is that we're seeing an expanded amount of things being brought into what each team is responsible for. So one example of that is security. Security is now everybody's problem. That's not some security department. Every developer needs to worry about security, and we need to think about security when we're doing story writing, for example. So all of this sounds great, right? This is Adrian Cockcroft, who's the architect for Netflix, and he was at a conference and he gave a talk about how Netflix's engineering culture does stuff. And he had a question in the audience from a Fortune 100 CTO who said, this is all great, this seems good, but you have Netflix developers. I don't have those people. I can't do what Netflix does because Netflix has great people. And Adrian said this: you did have those people. I hired them from you, and I got out of their way. So it is a white-hot talent market. The problem in IT is getting enough talent. People can choose where they want to go. So making your company an attractive proposition for people is incredibly important. All of this matters because technology is now at the core of business. Technology is at the core of society. Technology is moving at an increasing rate of change, which means that business is also moving at that speed. Time is against us. New adoption cycles are faster and faster. We used to have years to make a leap to new technology. Now we just have months. Organizations cannot afford to get technology wrong. Tech done right, agile done well, is the answer to that technology adoption. So we should celebrate. Agile has won. It's the right way to do software. Thank you very much.
네, 강연 감사합니다.
Thank you very much for the talk.
저 질문은 조직 간 사일로가
Should like to know about the silos in between organizations. The silo culture. It's a huge problem in Korean culture, especially. Organization is very vertical. It's not horizontal at all. If you want to suggest something with this cultural background, what do you suggest?
Thank you. That's a great question. Something that I think there's a couple of answers. One thing is to show that there is a better way. So to deliberately build a smaller piece of the organization that is not in a silo, that has people together, and then to show that that can produce better outcomes, because then you have more credibility when you suggest that. And the other thing I would suggest is looking at especially things like the Spotify description of how they do Agile, because they have a way of thinking about areas of expertise, because specialization is still important. So database experts are still important, but we want them on the team. But database expertise is an important professional area, and DBAs need to work with other DBAs to be really good at their job. So Spotify has a really interesting model. They call it squads and guilds and tribes, where you can be part of a team who are trying to produce a particular piece of software or a product or an outcome, but you can also be part of your professional DBA organization. And so that can help to sort of bridge the gap between those two styles.
네, 안녕하세요. 삼성전자 반도체 부문의
From Samsung Semiconductor. He's from R&D Center.
쪽 사업부 같은 경우에는
His business unit.
아직도 칸반을
Still,
주장하시는 분이
there are
계신데요.
a lot of people insisting we need to do Kanban.
그 에자일을 저희가 하고 있긴 한데
They're doing
저희
agile.
스프린트 단위로 운영하고
They're
있습니다.
using
그때
sprint.
2주간 스프린트 중에서
Every 2 weeks,
다른
they
이슈가
deliver
왔을 때
the product.
그것이 저희
When there's an
개발하는 데
issue,
있어서 인터럽트가 되지 않도록 그 이슈권을 스프린트에 끼어들지 않도록
they want to protect the sprint work. The Scrum Master is there.
네, 스크럼을 주도하시는 분이 2주간에
There's a Scrum
이슈가 새로
Master.
들어오지 않도록
But there's
막아주시는
an
역할을
issue
합니다.
to protect the
근데
team.
다른 분께서는
But other
이슈를
people
처리하는 게 더
say
급하다
it's
하면서
taking care of the
방식으로
issue.
하는 것이
It's
더
much more
낫다고
important.
주장하십니다.
So why don't we
네.
try Kanban?
새로운 이슈가
Like a
주변에
production
끼어드는 것을 막아주기 위한 스프린트 방식이 좋은지 아니면은
Do you think like
대자리
sprint is
방식으로
better
그런
or
것을
Kanban is
극복하고서
better?
개발을 할 수
And how we
있는지
can overcome
무엇이
this
진짜
kind of
미인인지
challenges?
그 칸반을 원하시는 사람을 어떻게 설득할 수
How can
있는지
we
그런 것을
persuade
알고
like
싶습니다.
person who is insisting to take care of the work with the Kanban?
Good questions. So I think it's important to think about the outcomes and that your team needs to deliver. It sounds like you're doing both development and support at the same time because issues come in that are important to deal with. Am I understanding that right? Yeah. So what we have done is sometimes we have organized the team so that we have a certain amount of capacity that is reserved for issues, and then the rest of the capacity of the team is for development. And using that, we use that capacity to do iteration planning and to put in the stories that we're going to try to work on. And then you just have, 2 people or 4 people on the team who are dealing with issues, and you protect the rest of the team. I think in general, the process that works for teams is often dependent upon the team, and they need to change their process to work with their environment. I don't have an answer. Is Kanban better? I don't know. It's going to depend on your team, but I think having clarity about what you're trying to do. Is new development important? Is support important? What is the trade-off? Clarity is the most important thing.
Yes, Mike, it's great to have you, somebody like you, provide excellent speech about this agile process and methodologies. Although I'm not sure I really understand everything that you talked about, but I'd like to still ask one question. It might be a very stupid question though. Ideally, in the company, we have enough good software engineers and maybe more software engineers than the number of projects. But in most of the cases, maybe the other way around. We have a number of projects and we do not have enough good software engineers. So in that situation, still we want to try the agile process and use such as that we talked about. Then what's the best way to share the specialists and excellent software engineers and make them to contribute to multiple projects? Time sharing? What's the best way in your opinion?
Okay, that's a good question. So I think something is very important to realize is that when somebody time shares between projects, their efficiency on each project is going to reduce. So the benefit from them doing that needs to be more than the efficiency reduction. So a good example is, very senior software engineers, architects, if they can spend 50% time on a project and help accelerate all of the people on that project, then it's worth them splitting their attention between, maybe two projects. So you kind of have to think about what is the acceleration that I'm going to get from doing the sharing. And I think the other thing that's very important is that within IT, we always need to be growing new people who can do the role. So if I am a tech lead on a project, one of my primary responsibilities is not coding. It's growing the team. Because I want to make myself redundant, because we have a new tech lead who is, younger and smarter than me, right? So I think those are the two things. I think a growth mindset where everybody is trying to help everybody become better, so you have more people who can do these things, and also understanding that time splitting is almost the last thing that you should do because of the efficiency reduction.
시간이 좀 많이 지났는데요. 다시 한번 좋은 키노트 말씀 주신 마이크 엑스에게 큰 박수 부탁드립니다.